Hey scientists, welcome to Over the Top Science. I'm Mr. Crouch. In today's lesson, we're going to talk about the physical property of volume. We'll talk about what volume is and what it's used for. We'll talk about some metric units for measuring the volume of both solids and liquids. We'll talk about some tools to measure the volume of solids and liquids. If you're going to participate in today's lesson, you're going to need a centimeter ruler, a measuring cup, any size, a rectangular prism. That could be a tissue box, a pencil box, or any rectangular prism. And if you have access to graduated cylinders and beakers, that would be great. Let's get started. Okay, so let's take out our science journal and title a new page, Measuring the Volume of Matter. Make sure you capitalize all important words and underline your title. We'll review the definitions of matter and mass from previous lessons. Matter is anything that has mass and takes up space, and mass is the amount of matter in an object. When you think of mass, I'd like you to think of weight. It's not the exact same thing, but the number on Earth is always equal. So matter is anything that weighs something and takes up space. Now let's skip a line, and the title is Measuring the Volume of Matter. Let's write the definition of volume. And volume is the amount of space an object takes up. Make sure you underline the definition. So with mass, I told you to think of weight. With volume, I'd like you to think of size. It's the size an object is. And let me give you an example. I have two lamps here. One is larger than the other, so this lamp has more volume than this lamp because it is larger. Let's look back at the definition of matter again. Matter is anything that has mass and takes up space. So we said volume is the amount of space an object takes up. So we could actually rewrite the definition of matter as anything that has mass and volume. So matter is anything that weighs something, and how big something is. All right, so we're going to start with liquid volume. As a reminder, volume is a property of matter. It is a property of matter that can be measured, and we're going to discuss how to measure liquid volume. So skip a line in your science journal and write measuring liquid volume and capitalize all the words. We'll skip another line and write the metric units for liquid volume. And the metric units all start with the liter. Now, to give you an example of what a liter is, you generally have a drinking bottle. You might, on your desk at school, something you usually get a small size, an individual size for yourself. Well, 2 of those is 1 liter. If you look on the label, you might see 0.5 liters or 500 milliliters, but that is half of a liter. So 2 of these is 1 liter. So the base metric unit is the liter. And the abbreviation for liter is L. And you could put 2 water bottles or 2 drinking water bottles or whatever. If you drink Zephyr Hills, you may want to draw a little picture of the Zephyr Hill bottle. There's also Dasani and whatnot. 2 of those is 1 liter. Now, just like when we talked about grams and milligrams and kilograms, well, liters work the same way. We're going to put a prefix in liter to make it smaller. So the next one is, what is it? You guessed it, the milliliter. And the abbreviation for milliliter is ml, small ml. Okay, so the smallest liter is the milliliter, which is 1/1000th of a liter. Then the liter, and then the largest one, yeah, you guessed it, kiloliter. And kiloliter's abbreviation is KL, small KL. And the prefix kilo means 1,000. So it literally means 1,000 liters. So 1 kiloliter is 1,000 liters. So that'd be about the size of a bathtub. A bathtub full of water is about 1 kiloliter. So 1 KL equals 1,000 liters. Which is about a bathtub full of water. So let's put that. And probably draw a little picture of a bathtub filled with water. Okay, we're going to go ahead and go through some of the science tools for measuring liquid volume. So skip a line in your science journal and write science tools for measuring liquid volume. I'll write that down and we'll come back to it after I review the tools. Pause the video if necessary. Okay, the first science tool I'd like to discuss for liquid volume, this is a pipette. A pipette's capacity is usually about 1 milliliter. So just to give you an idea, this here is about a milliliter of water. And this again is a pipette. The next one is something you have in your house. This is a measuring cup. And the way measuring cups work is it's called a measuring cup because a cup is a standard unit. But almost all of the measuring cups also have milliliters on the side. And you will see this one here goes up to 500 milliliters. So this one has a capacity of 500 milliliters. And this is a much smaller measuring cup. And this one has a capacity of 275 milliliters. So this is 275, and this one's almost twice as big, and this one's 500 milliliters. And again, these are measuring cups, and they're for liquid volume. The graduated cylinder. This here is a 100 milliliter graduated cylinder, and this one's capacity is 1/4 the size. This is a 25 milliliter graduated cylinder. So you see this one's 1/4 the size. This one, this one's taller and fatter, so it's held 4 times as much as this smaller graduated cylinder. The last thing I'd like to discuss with you is a beaker. This is a 250 milliliter beaker, and to show you 250 milliliters of water, it looks something like that's 250 milliliters of water, and this here is 500 measuring cup. So it's half the size. So those are your measuring tools. Alright, so go back to your science journal and we're going to go ahead and fill in the science tools. The first one we talked about was a pipette. So go ahead and make a bullet and write the word pipette. And let's go ahead and draw a picture of a pipette. You see the really neat picture I drew. And a pipette's capacity is about 1 milliliter. After the pipette, we discussed the measuring cup. That's the tool that you can find in your house. They come various sizes, as small as 100 milliliters. I see them as large as 500 milliliters. Here's a picture of the 500 milliliter measuring cup. Following the measuring cup, we had the graduated cylinder. That's a tall one. It looks like a tube with a base. They come as little as 10 milliliters, maybe even 5 milliliters, and they go as large as about 500 milliliters. So that's a very simple one to draw. The last one we discussed was the beaker. Kind of looks like a glass with a rim on it, and of course has the metric units on the sides. When you're discussing the science tool, the metric units are always either milliliters or liters. You won't see kiloliters because of the amount of water a kiloliter is. Since a bathtub full of water is a kiloliter, there's not many things in the science classroom that you're going to see that's going to hold a bathtub full of water. So on the sides of all your tools, you'll see either ml or L. Okay, we're going to begin measuring the volume of a solid, actually a rectangular prism. And for this section, what we're going to need is a ruler with centimeters. And you know it has centimeters because you'll see cm or mm, and it goes up to 30 on your ruler. We'll need a rectangular prism, something like a tissue box. or any rectangular prism would be fine. Okay, so let's skip a line in your journal and write volume of a rectangular prism, and we're going to go through the steps. So step 1, what we're going to do is we're going to measure the length, width, and the height. So write a capital L for length, a capital W for width, and a capital H for height, and we're going to measure it and insert the numbers in centimeters. Pause the video and catch up on the notes, and let's get our rectangular prism and our centimeter ruler. Alright, so I'm going to measure the length, width, and height. To find the length, you just put it down, just sit it down so it's setting regular, and you're going to measure across the front in centimeters. You want to make sure that you line it up on the first line and not the edge of the ruler. And what I'm going to do is I'm going to find the nearest whole number. Well, it's closest to 9 centimeters, so the length is 9 centimeters. And we'll write that down. Now I'm going to do a quarter turn. Now, to do that, I'm going to match the width. So I'm going to go ahead and look at that. And that is also closest to 9 centimeters. So now I have the length and the width. Now to get the height, what you want to do is you want to measure it from top to bottom. And again, you want to hold it on the, put it on the line, and it looks like it's closest to 14. So I have a length of 9 centimeters, a width of 9 centimeters, and a height of 14 centimeters. So let's go ahead and log that in. Okay, so let's enter the length, width, and height. We said the length was 9 centimeters. We said the width was also 9 centimeters. And we said the height was 14 centimeters. All right, so now we're going to go on to step 2. Step 2, we're going to use a formula, volume equals length times width times height. So that means we're going to multiply the numbers. So you might also see it like this. And we're just using the V is volume, L is length. Dot means multiply length times width times height. So you might also see it that way. Spend a moment and catch up on your notes, and then we'll figure out the volume of the rectangular prism. Pause the video if needed. Alright, so we said volume equals length times width times height, L times W times H. So our length is 9. So 9 times our width is also 9. 9 times 9 is 81. So now we're going to take our 81 and multiply it by the 14. So 81 times 14. Why don't you go ahead and do that, and we'll get our answer. All right, so what'd you get when you multiplied 81 times 14? You should have gotten 1,134. So the volume equals 1,134. Now you must always label your answer. So we're working with centimeters, so centimeters. And since there are 3 things, you put a little 3 here, which means cubed. 1,134 centimeters cubed. So volume equals 1,134. Our unit is centimeters and cubed. So we're saying this is 1,134 centimeters cubed. So as a scientist and a math guy, I asked, does that make sense? That sounds like a really big number. Well, let me show you this. This thing here you might have seen in math class. And this is a math cube, and it's actually 1 centimeter cubed. It is 1 centimeter wide by 1 centimeter long by 1 centimeter high. So 1 times 1 times 1 is 1 centimeter cubed. So we're saying it takes 1,134 of these to form this shape here. Well, that's starting to make a little bit more sense, but let me show you even more. You might have seen this in math class. This is 100 of these. So this is 100 centimeters cubed. So let me show you. This here is about the same size as the top. So this, if it was this big, it'd be 100 centimeters cubed. If I put another on, it's 200 centimeters cubed. So we go higher, it's 400, 600, 800, 1,000, 1,100. So we could see this is over 1,100 centimeters cubed. So our answer does actually make sense. 1,134 centimeters cubed is a reasonable response. Okay, we have a practice question. Carlos wanted to find the volume of a small box. The length of the box is 10 centimeters. The width of the box is 5 centimeters. And the height of the box is 9 centimeters. What is the volume of the box? Be sure to label your answer in cubic centimeters. So first thing you want to do is write down the formula for volume and then use that to figure it out. Make sure you write centimeters cubed after your answer. Go ahead and pause the video and find your answer. Okay, did you get your response? Well, first, what's the formula for volume? Okay, well, volume equals length times width times height. V equals L times W times H. So the length is 10. So 10 times the width. The width is 5. 10 times 5 is 50. So bring the 50 down. Now times the height. The height is 9. 50 times 9. Well, 9 times 5 is 45. Plus 1 0 is 450. Our units are centimeters. cm, and then cubed, which is a little 3. So 450 centimeters cubed. Okay, it's time for your journal entry on volume. Question 1. Name some science tools for measuring liquid volume and the metric units associated with the science tools you listed. Question 2. Pick one of the science tools you mentioned in question 1 and write in detail how you could use it in the science classroom. And question 3, dealing with the volume of a regular size solid. Ashley has a box that is 10 centimeters long, 5 centimeters high, and 4 centimeters wide. What is the volume of the box? Be sure to label your answer correctly. Pause the video, write down the questions or the important parts, whatever your teacher tells you, and take your time. Okay, scientists, I hope you enjoyed today learning about measuring liquid volume and measuring the volume of rectangular prisms. In the next lesson, we will learn to find the volume of solids that are irregular size. If you have any questions or comments, please email over to topscience@gmail.com. Happy science, everyone.